Okay, now today we will learn about simultaneous equations. Simultaneous equations are the set of equations having same variables. If we want to solve such equations to find the exact values of variables, we need to solve them together. We have different methods to solve simultaneous equations. Today we will explore one of the method or maybe more than one methods and solving different examples from the simultaneous equations. So, if we did discuss simultaneous equations or the set of equations, sometimes there are two equations, sometimes it's more than two equations. But the number of equations depends upon how many variables are involved. If there are two variables involved, there can be two equations. But if there are more than two equations, then it means there are more than two variables that for which we have to find the exact values. So for a simultaneous equation, as we did discuss, they are the set of equations. Having same number of variables. Okay, so having same number of variables. Right. Then how do we solve such equations? We have few methods. Sometimes elimination, sometimes substitution, and sometimes comparison. So most of the students feel easy to use the substitution methods. Others also feel easy to use elimination method. We would be using both these two methods in today's lesson. So we'll start with the substitution method, and then we may use the elimination method as well. Okay, now we will take an example of the equation. As we did discuss, they are set of equations. The most simple and at our level, mostly the equations, there are two simultaneous equations that we have to solve involving two variables. So if a question or an example is like that, for example, let's say 2x minus y equals to 17 and x plus y equals to 5. Now, this is the first equation, and this one is the second equation. If we want to solve these two equations together, it means we need to find the exact values of x and y that will satisfy each equations. Means those values of x and y will be the solutions for equation 1 and equation 2. As we first will solve for x and y by the substitution method, in this method, what we actually do is we need to take one of the equation and make any of the variable as a subject of the equation. Then we'll use the value of that variable in terms of another variable which we will get. We will use this value in another variable, in another equation, pardon me. that equation then will be only a single variable equation. Let us see how do we proceed. So if we are given with these two equations, we can use one of the two equations. Let's say I use the first equation. So from equation 1, what I'll do is, as the equation 1 is 2x minus y equals 17, I can make y as a subject of this equation. Pretty easy. So if I make y as a subject of the equation, you do know that you have to do operation, take y to the other side and 17 to this side. So clearly 2x minus 17 is equal to y. Now this value of y we can use in the second equation. And what you'll notice that the second equation will then be our equation involving one variable only. So use this in 2. All right. Then if we use this in 2, we have x plus y equals 5, which was the equation 2. Now we'll use the value of y from 1. It's x plus 2x minus 17 equals 5. Then we'll just simplify the left-hand side. So we would have 2x, x plus 2x minus 17 equals 5. Writing like terms together, it'll be 3x minus 17 equals 5 plus, okay, I'm sorry. Then equals 5. Then we now have the equation only in x. Now we take the 17 to the other side, and we would this way find what's the exact value of x is. Because now we have equation only in x, then we can find the x. That value of x, after that, we will find the y value as well. That values of x and y will be correct, will be the solutions for both these equations. That's what we meant to solve them together. Means we will just play with both these equations, take one, make y as a subject, use the value of y in another. So you are using both these equations, not the only one alone. You have to use both these. So we need to use both these to solve them together. Here we would have 3x equals 5 plus 17. These are the quite simple operations. If we want to move a number or a variable from one side to another side, the operation is reversed. 17 was minus here. It was 3x minus 17. If we take it to the other side, it will be 3x plus, or 3x equals 5 plus 17. Then we would have 3x equals 22, and then simply we can write 3. We have to take the 3 to the other side as well. Eliminate the 3 from left-hand side so that you would have only x, the exact value of x. Then you would have x would be equal to 22 divided by 3. It's clear that if you want to eliminate the 3 on the left-hand side, what we need to do, we have to divide it by 3. So we have to divide 3 on both sides. That's why if you eliminate it, then divide 3 on the other side as well. X would be 22 by 3. Now it's pretty simple. You have the exact value of x. We will use this value of x either in equation 1 or in equation 2 to find the exact value of y as well. So we can put this in 2, which is pretty simple to solve if we just directly put this. It would be 22, instead of x, we'll write 22 by 3, right? So it will be 22 by 3 plus y equals 5. Now, similarly, we want to find y. We have to take 22 by 3 to the other side. Then this way, we would have only y to the left-hand side equals to some number. So y would have the exact value. If we take 22 by 3 to the other side, then we would have 5 minus 22 by 3. And we can solve this considering this is a fraction and a number. So we would have, pardon me, I have to take this to the other side. So now we would find what's the exact value of y is. It's if we just solve this side, we can write 5/1. 5 can be also a fraction. 3 times 1 is 3. So 5 times 3 cross multiply minus 22. Why we did this? Because if we want to solve two fractions, if we want to add or subtract two fractions, we just do it by taking an LCM or by just simply writing that into one fraction in a way that the denominator of that fraction would be the product of the denominators of the individual fractions. In this case, I just wrote 5 as 5/1, so it should appear as a fraction. 5 or 5/1 is the same thing, right? So now you have two fractions subtracting. We are subtracting two fractions. How do we simplify it and write that in one fraction? It would be denominator with the denominator, 3 with 1. So you can write 1 times 3, which will be 3. And numerator of that simple one fraction actually is by cross product. So it's 5 times 3 and minus 22 times 1, right? Which is 22. So you'll get the answer y equals 15 minus 22 over 3, which is minus 7 over 3. Note that we don't have enough space to sometimes write all this working, but all the working we have to show in the exam questions, because sometimes exam questions involving simultaneous equations are a 4-mark question or a 5-mark question. So for that, you may not have to miss any of the step that would impact your answer negatively, so the examiner can cut the marks. So for example, if your answer starts from here, if you start writing, try to write in columns so that all the available space is used very effectively, and every step of the answer is also clear, and you get the full marks, or hopefully the full marks or very good marks in that question. Now, we will now solve another equation, another simultaneous equation that can be in such a form that one is a quadratic and the other is a linear. So that would have a little more working than the two linear equations. For example, we can consider this, or maybe another equation if we have I'll be writing questions on my own, but you can expect the similar questions, or at least the questions are very they are very likely like that. Conceptually, you would expect similar kind of questions. So, for example, if we have a question which says that x minus y equals 3 and x square plus 2y square equals 9. This is equation 1. This is equation 2. And we have to solve it for x and y. What are those values of x and y for which will be the solutions of both these equations? So if we have to solve for x and y, then again, I'm going through substitution method. In this case, in such type of equations where one is quadratic and the other is linear, the most recommended method, the most suitable method is the substitution method. Elimination, sometimes not possible if this guy is also a y square. I mean, both of the variables x and y have the degree 2, because if both have the degree 2, we cannot eliminate x or y by just adding or subtracting or doing some operations. Yeah, by chance, if we have one variable have the degree 1 and the other variable x has a degree 2 in that case, so we can still eliminate y. What we have to do is we have to make 2y here, so we need to multiply equation 1 with 2 and then just add them, add these both equations, and then you would see that after adding, y is gone, you would have only equation, a quadratic equation in x only. But in this case, I'll go for a substitution method again, as we have, pardon me, as we have uh, degrees of both the variables as 2. So both variables have square power. Now I have to use equation 1 again. From equation 1, I'll take the x value and substitute that in 2 from 1, as the one is x minus y equals 3, and x then will be equals to 3 plus y, right? A simple operation. We need to take y to the other side or eliminate y from this side, add y on both sides. On left hand side, the y should be eliminated, and on right hand side, it appears as 3 plus y. Now we will use this in equation 2. Okay, so if we use this in equation 2, now we have equation 2 would be x squared, and instead of x squared, x is 3 plus y, so it should be 3 plus y squared plus 2y squared equals 9, right? Now, we will expand the square. For square, it should be 3 squared plus 2 times 3 times y plus y squared, and this one, this term, 2y squared equals 9. Then we will have 3 square is 9, 2 times 3 is 6y, and y square plus y square is 3y square. So we will add the like terms together and simplify the left-hand side. It should be 3y square plus 6y plus 3 square is 9 equals 9. Now, what we notice that, again, what we notice that this plus 9, if we take it to the left-hand side, so to make the equation look like a standard quadratic equation of the form a y squared plus b y plus c. So we would get 3y squared plus 6y plus 9 minus 9 equals 0. We have to take this 9 to the left-hand side, eliminate from the right-hand side, so we have to subtract it on both sides. On right-hand side, the 9 disappears, and on left-hand side, it appears as minus 9. Now we would have 3y squared plus 6y, as because plus 9 and minus 9 cancels out, we have 3y squared plus 6y equals 0. If we factorize this, we have to take 3y as common, and inside the bracket we would have y plus 3 equals 0. Clearly now you would have two solutions for y. It was a quadratic equation in y, so y would have two values. One of the value is either 3y equals 0 or y plus 3 equals 0. From here, you get y equals 0, and from here, you get y equals minus 3. Now, if you have two values of y, you would definitely have two values of x as well. So we will use these two values of y in equation 1. So first, use y equals 0 in 1. So what will be x? X minus 0 equals 3. Then x would be equal to 3. You get one solution set as x3 and y0, correct? Okay, we will get another solution set as well for x and y. Uh, if we use y equals minus 3 in 1, so use y equals minus 3 in 1. We would have x minus into minus 3 equals 3, which would be x plus 3 equals 3. And then x equals, we need to find x, take plus 3 to the other side, eliminate from left side. So it would be minus 3 on the other side. X is 0. So clearly if we use y equals minus 3, we get x to be 0. We get another solution set which is 0 and minus 3. Now, these are the values of x and y, two set of values that will satisfy both these equations. It's very obvious that if we use this 3 and 0 in equation 1, which reads as x minus y equals 3, so 3 minus 0 equals 3, 3 equals 3. If we use the same in equation 2, it will be 3 square plus 2 times 0 square equals 9, 2 times 0 square is 0, 3 square is 9, 9 equals 9. Similarly, if you use the second set of values, it would also satisfy. These so far were the linear equations, set of equations they are, which we were solving. And the number of equations depends upon the number of variables. Now there are two variables unknown, so there will be two equations that you have to solve together. If there are three variables, there must be three equations at least that you have to solve together. The methods, we did learn about substitution, the most commonly used method. People also use elimination, which we will learn later. So from substitution, we did see that the equations that we are solving, if both are linear or if one is linear and the other is quadratic, in that case, if one is linear and the other is quadratic, and the quadratic one have both variables with degree 2, or both variables has a square power, so the most recommended, most reliable and suitable method is the substitution method, right? So that was the substitution method and solving simultaneous equation from this method. I will see you in the next lesson. Have a good day.